Hello, your friendly neighborhood Mr. Stone here to talk to you today about Z-scores, and you know that they've got to be cool because they've got a really cool name. So far, we've looked at normal distribution and what that tells us about where exactly the data lies. So if we know that right here, we've got our average, our mu, and I've got my one standard deviation here to the left, well, I know that 34% of my data values are going to be between the mean and the one standard deviation to the left. Similarly, I could do something over here and go one standard deviation to the right, and I know that I have 34% here, and that's all fine and dandy, but what about those cases where we don't have a very tidy uh, distribution like this, where I don't know exactly that I'm one standard deviation away? That's where these z-scores come in and why they are so awesome. So let's take a look at a z-score. First of all, the formula to get a z-score, if you have some point that you want to know, we'll call it x, you can subtract your mean from that, subtract mu, divide by the standard deviation. That gives you your z-score. And well, what do we do with that? Well, using that and a nifty table that I will give to you, then you are able to tell what the area is under that curve. And really the area is just the same, more or less, as your percentage of beta values that are within that range. So let's do an example, and I think this will make a lot of sense. Uh, so let's suppose that this is a I heard this the other day, that Americans watch 34 hours of TV per week. And maybe you're thinking, wow, that's a lot, or maybe you're thinking, that's like me. Um, that is our average, so we're going to call that our mu, our mean. And let's say that the standard deviation on that is 6. Okay, 6 hours. So now that we've got our mu and our sigma, all we need left is our x. And now I'm curious, well, I'm going to estimate here that I watch maybe about 24 hours per week. I just don't have enough time for TV, which could be a good or bad thing, I suppose. But 24 hours per week, and that is my x. That's the thing that I really want to know about. So I'm going to go back to my formula of x minus mu over sigma. And I'm going to start plugging in here. So I said my x is 24, so 24 minus mu right here. We said that was 34. Divide all that by sigma, which was 6. Okay, and now I will simplify this. So 24 minus 34, well, that just gives us negative 10 over 6. And we can reduce that, right, to what can we reduce it to? Negative 5 over 3. And we will want to get this in terms of a decimal. And negative 5 over 3, it's a good handy one to know. We're going to say that our z-score in this case is equal to negative 5 over 3, but more importantly now we need this in terms of a decimal, which we would say would be negative 1.6, and we're going to round to the nearest hundredth, negative 1.67. So where I go from here is, now that I've got my z-score of negative 1.67, I go to a handy dandy chart, and you will see all sorts of stuff here. On the left, it'll start like, usually you start about negative 3, and they go, and then you got negative 2 down here, and there's some stuff in between. Eventually, you want to go down here to negative 1.6. All right, that will be on the left-hand column. And then you're thinking, well, hey, I've got negative 1.67. What the heck happened to this 7? Is it getting shortchanged? What's going on? Up on top, you will see that you've got like 0.09 up here, 0.08. Just find 0.07. And then follow that guy down, and then where the two meet, that will give you something. In this case, for negative 1.67, it gives me 0.0475. All right, and what this is telling me is that if I did my normal distribution here, and we said the average was 34, and then here I am about 1.5, a little over 1.5 standard deviations away at 24. This 0.0475, that is the area here. That is this area, and this is the percentage of values that are equal to or less than 24. Okay, and 0.0475, that's the same thing as 4.75%, right? So we could say that about 4.75%, or just shy of 5%, watch about as much television per week as I do. Okay, assuming that all of our data there is accurate. And that's it. That's how we use our z-score. In this case, again, my z-score was negative 1.67. And using that, I'm able to determine this value right here. Well, actually, both of these guys, right? Because they're fundamentally the same. All right, so that's using a z-score. Let's do one more example here real quick. So let's say that I am a television executive and I'm planning advertising and all that stuff, and I want to know how many people are watching between 30 to 36 hours per week. So what I can do is I can find the z-score for each one of these guys individually, and I will start with 30. So I'm using, again, my formula, x minus mu over sigma. I do 30 minus 34 over still standard deviation of 6, and this gives me negative 4 over 6, which is just the same thing as negative 0.67. So that's my first one. And then I'm going to do the same thing over here. I'm going to do 36 minus 34 over 6. And this gives me 2 over 6. Note this time that my result is going to be positive. I'm going to have a value of 0.33. And quite often the z-score tables are divided amongst negative and positive. When it is negative, that means that you are on the left half. So everything over here is negative, and everything that's over here is going to be positive. Okay, because you're subtracting your mu from it. You're subtracting your mean from whatever your x is. So if your x is greater than your mean, then yeah, you're going to be over here on the right. And if it's less than the mean, then yeah, you're going to be over here on the left. So I've got two values, negative 0.67 and 0.33. Let me find the areas. Consulting my z-score chart, I see if I look up an area here of for negative 0.67, that gives me 0.2514. And if I do the same thing for, that was for negative 0.67, if I do the same thing for 0.33, that gives me my area under the curve would be 0.6293. So over here I've got something like this, and there's my mean, and then I'm looking at the area maybe about right here. Okay, those are the people that are less than, we said 30 hours. So 30 would be right there. Okay, right. And over here, this has given me a value of, here I am just to the right, here's 36, pardon my terrible drawing skills, but in the area of everything here, which is all that, is 0.6293. Now, I notice I've got some overlap here. I've got this section right here on the left is actually inside of this. Okay, I could cut it like about right here. So what I'm going to do in order to figure out the area, all I'm really concerned about is, let me change colors here. All I'm really concerned about is this area right here in between. So to get just this red part, I'm going to subtract this, which is my 0.2514, from 0.6293 so that I don't count the same thing twice. Okay, so if I do 0.6293 minus 0.2514, what do I get? And we should have 0.3779. And what this tells me is, let me go back to, let's do green because green is good. What that tells me is that if I'm right here, there's my mu again. We said this was 34. And here is 30. And a little bit closer on this side, there's 36. All this area right there is at 0.3779, or about 37.79%. This area down here that was cut, that is the 0.2514. I'm not using that. I had to subtract that from the area, from this whole thing over here, in order to get just the desired part that I wanted. All right? Think if you have any questions, and we will go over this. Thank you for your time, and I hope you have a fantastic day.